The action potential consists of three phases, each resulting from shifts in voltage or changes in charge across the cell membrane that selectively open ion channels and allow ions to flow across the cell membrane. During the first phase, voltage-dependent sodium ion channels in the cell membrane open and allow sodium to come rushing into the neuron. Sodium brings its positive charge with it, which changes the charge inside the neuron to positive. Since the inside of the neuron is becoming positive with the influx of sodium, the change in electrostatic pressure results in the opening of potassium channels, and positively charged potassium flows out of the cell. The sodium channels then close, and the peak of the action potential is reached. As the influx of sodium decreases, potassium is still leaving, resulting in a temporary hyperpolarization of the cell membrane potential. When the potassium channels close, the sodium-potassium pump begins exchanging potassium and sodium again, and the baseline potassium level is once again restored on both sides of the membrane. Once triggered, action potentials proceed down the axon to the terminal ending. Action potentials abide by all or none law. Once depolarization or an EPSP reaches threshold, an action potential will occur, and it can't be cancelled. Just like sending a text from your cell phone, once you hit send, off it goes, and you can't stop the message from being delivered. Many axons are covered with an insulating substance called myelin. The myelin is wrapped tightly around the axons, and it speeds up the rate of neural communication. In other words, the action potential will travel much more quickly down a myelinated axon than a non-myelinated one. The process of traveling down a myelinated axon is called saltatory conduction. The myelin squeezes all of the sodium channels to concentrated regions between successive patches of myelin. These myelin-free areas are called nodes of Ranvier. Saltatory conduction involves propagation or jumping of the action potential down the axon from node to node of Ranvier. Once the action potential reaches the terminal ending, the neuron releases neurotransmitters, also known as chemical messengers, into the synaptic cleft, which is the space between neurons. These neurotransmitters are what carry information from one neuron to the next.